Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on February 23, 2026, just yesterday. It introduces a new framework that outperforms state-of-the-art reinforcement learning orchestrators by about 23%, while reducing learning costs by up to 700 times. The paper is titled SkillOrchestra, Learning to Route Agents via Skill Transfer. And as we'll see later, the results suggest that explicit skill modeling offers a powerful alternative to data-intensive training for compound AI systems. Well, Figure 1 illustrates the accuracy versus cost trade-off, where the ideal spot is the top left corner. On the left chart, covering multi-turn model routing, SkillOrchestra and SkillOrchestra Plus claim the Pareto frontier. They achieve higher accuracy than heavy hitters like Llama 370B or Router R1, but at a much lower price point. Moving to the right chart for agent orchestration, the advantage is even clearer. The system outperforms massive proprietary models like GPT-5 and Claude Opus 4.5, showing that smart skill modeling can beat raw scale. To understand the source of these gains, Figure 2 compares the architectural approaches. The left panel depicts traditional model routing, which statically selects a model based on the query, but fails to adapt as the task progresses. Next, the middle panel shows direct agent orchestration. This adds tools but suffers from routing collapse, where the policy lazily defaults to a single expensive agent. Finally, the right panel introduces SkillOrchestra. The key difference here is the skill handbook, which explicitly maps the current context to specific skills and agent profiles, ensuring a balanced and cost-effective choice for every step. With the concept established, Figure 3 details the workflow across 3 phases. On the far left, the skill handbook learning phase starts by mining raw traces from agent executions to build a structured handbook containing skill definitions and agent profiles. Next, the center panel shows handbook selection. Here, the system validates candidate handbooks to find a Pareto optimal subset, which represents the best possible trade-off between reward and cost for a specific orchestrator. Finally, the deployment phase on the right illustrates the runtime loop. At each step, the orchestrator uses the selected handbook to first decide the operational mode, and then route the task to the most cost-effective agent capable of the required skills. So, while the previous figure outlined the workflow, Figure 4 now opens up the black box to show exactly what a skill handbook looks like inside. It organizes knowledge into 3 distinct components. On the left, the mode metadata acts as a high-level strategist, containing rules for when to switch operational modes, like moving from search to coding for complex calculations. In the middle, the skill registry breaks these modes down into fine-grained capabilities, such as defining symbolic logic as a specific subskill of coding. Finally, the agent profiles on the right map these skills to specific models, listing performance scores and costs, so the orchestrator can make an informed choice. Alright, turning to the concrete results in Table 1, we can see how this handbook-based approach stacks up on general and multi-hop QA tasks. The upper sections list standard baselines, including no routing and heuristic methods, which struggle to break past 34% average accuracy. The strongest competitor here is in the RL-based routing section, Router R1, which achieves a respectable 41.6%. But looking at the bottom rows, SkillOrchestra outperforms them all. The standard version jumps to 47.4%, and the enhanced SkillOrchestra Plus climbs even higher to 51.6%, delivering a solid 10-point lead over the best reinforcement learning model. Well, Figure 6 explains why the method is so efficient by analyzing actual routing decisions. On the left, the pie charts reveal that Router R1 suffers from routing collapse, sending 98% of traffic to the expensive Llama 3.1 model. SkillOrchestra, however, balances the load, calling the heavy Mixtral model just 45% of the time. On the right, the bar chart shows that a handbook learned by a small QN model boosts other backbones without retraining, consistently driving the blue accuracy bars far above the baselines. Wrapping up, 2 takeaways stand out. Explicit skill modeling offers a scalable alternative to data-intensive reinforcement learning, and it effectively solves routing collapse. By decoupling skills from specific agents, SkillOrchestra achieves superior performance with vastly lower training costs. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.